Hello and welcome to this presentation. My name is Michael Ogilvie, and today I will introduce you to the PulmoVista 500, a brand new regional ventilation monitor set to change respiratory care. PulmoVista 500 uses the technique of electrical impedance tomography to display information about ventilation-related changes of air content in a cross-section of the chest. PulmoVista 500 quantifies the distribution of ventilation, as well as providing quantification of regionally specific changes in end expiratory lung impedance. It is intended for bedside use, particularly in the intensive care unit. Let's see how PulmoVista 500 works and how the information is provided. Using a silicon belt with 16 integrated electrodes around the chest, PulmoVista 500 sequentially applies a small current across two of the electrodes, while the resulting voltage changes are measured at all the other electrodes. Data from the voltage measurements associated with each complete rotation of current application is used to create an image. Up to 50 images per second can be displayed to form a real-time dynamic image of ventilation. All the information displayed on PulmoVista 500 relates to the ventilation-related changes of air content that occur in the area covered by the electrode belt. It's easy to get measurements underway. The belt is simply applied around the chest and then measurements can be started. An automatic calibration individually optimizes image generation. Now, let's take a closer look at the elements of the main view of PulmoVista 500. Firstly, the dynamic image, a real-time cordocranial view of ventilation-related impedance changes. The distribution of ventilation is displayed according to this colour scale. The black areas indicate there is no ventilation. The darkest blue areas indicate minimal ventilation through to the white areas which show maximal ventilation. The next element of the main view I will show you is the global impedance waveform. This waveform, bearing a strong correlation to a ventilator volume waveform, shows the impedance changes in the electrode plane. The lowest point corresponds to the end of expiration and the upper point corresponds to the end of inspiration. Next, let's take a look at the tidal image, which shows the impedance changes of the last detected breath. Regions of interest, that is, ROIs, are set in the tidal image. There are always 4 ROIs. The user can choose how they are arranged, either to facilitate evaluation of distribution of ventilation in a ventral-dorsal orientation or as well in a left-right orientation. The distribution of ventilation corresponding to each ROI is also displayed as a regional impedance waveform and as a numerical value, the regional tidal variation. And now, let's move on to the trend view, which enables comparison of the distribution of ventilation at 2 user-selected cursor positions along the time axis. The distribution of ventilation is displayed for each cursor position, while a differential image shows the difference between the images at each cursor position. Before explaining the next view, I will introduce a new term, delta end expiratory lung impedance, referring to the changes in end expiratory lung impedance which occur on a breath-to-breath basis. This term can be shortened to DELI. The DELI trend view is dedicated to comparing and quantifying regional changes in end expiratory lung impedance. Quantification is based on the user-selected position of 2 cursors. A differential image provides clear visualization of regional increases and decreases of end expiratory lung impedance. This view may help to distinguish between further inflation of lung regions which are already inflated and recruitment of lung regions. Data, which can be imported from Draeger Evita family ventilators, is integrated into various parts of the PulmoVista 500 display. Here in the DELI trend view, we can see a trend of PEEP values, making it much easier to understand the relationship between PEEP settings and end expiratory lung impedance. Regardless of which view you are using, it's always possible to access a number of additional functions. Here, we can freeze the screen or export a screenshot. EIT data can be recorded and reviewed. The signal check window gives a clear view of the skin electrode impedance of all electrodes. PulmoVista 500 has been designed so that it is easy to operate, Minimal user interaction is required to display distribution and ventilation, even over a period of hours. I hope I have been able to give you an insight into how PulmoVista 500, a brand new regional ventilation monitor, is making ventilation visible.